When you multiply, add exponents. When you divide, subtract exponents. For an exponent of an exponent, you multiply. For a negative exponent, take 1 over the positive. That's exponent.
All right, well, welcome back, Algebra 1 students. This is Chapter 6. We are looking at exponents in this chapter. I wanted to do that just as a way of review, just to remind you of just those exponent rules. They are very important that you don't forget those rules, as we've learned already in Chapter 6. And we're going to be going on now to 6.5 here with Algebra 1, solving exponential equations in this lesson. So we'll be solving them with the same base. So we'll be solving exponential equations with the same base, and that is going to be the easier ones to solve. It'll get a little bit more difficult when we start to solve exponential equations with unlike bases, where the bases are not the same. And then also we'll be solving exponential equations by graphing. We'll be using a graphing calculator to be able to do that with. So we'll be going over that there at the end. All right, so first of all, let's go into a little cartoon. So here's the one. It's in the winter, some snow's falling, little boys trying to catch the snow, and then some pigeons are above him. Hey, are you thinking what I'm thinking? This is probably one of my all-time favorite cartoons I've seen. I just love that one. It's funny and gross at the same time. All right, well, let's go on to looking at page 190 there in your journal book. This is where it says exponential equations. What should you write there for that on the vocabulary? And I underline what you should write. Exponential equations are equations in which variable expressions occur as exponents. So if the variable expression that we typically are solving is now going to be in the exponent position. And you can see the core concept right there on the same page. We can see how we can talk about it in words. Two powers with the same base b are equal if and only if their exponents are equal. So we can also look at the numbers. If 2 to the x power is equal to 2 to the 5 power, then we can just say x equals 5. So basically what we see here, since the base is the same, they're both a base of 2, 2 to the x, 2 to the 5th. When you have the same base, we can just kind of cross out those bases right there. They cancel each other out, and now we just have what's left for the exponents is the equation. So x is equal to 5, and that's what we have. So now if you have more of an expression in these two, you're going to set them equal to each other, and you might have some more solving left to do. So let's go on and try some of these now. So right there on the extra practice. So here we are on page 191 there in your journal book at the top. Now I'm going to do number 4 first with you, and then you're going to go back and try 1, 2, and 3. They should be very simple to do. So for number 4, what we're doing there, since they both have a base of 5, and there's an expression for the exponent. So these bases of 5, we can cancel those bases out, and now what the exponents are going to be equaling each other. And so there we go. With this exponent is going to now equal the other exponent. The exponents are equal to each other, and now we can just solve for x just like we've done before in the past. So we could maybe get the x's all on one side. So I could either subtract 4x from both sides. No, let's see. Actually, I put a negative in front of that 6, and I shouldn't have. That is a positive. Somehow I thought that looked like that was actually just a little part of the 5. So really, 6x minus 3 for this exponent, negative 3 plus 4x. There we go. And so now we want to subtract our 4x. We can do that from both sides. And so it gives me now 2x here. Minus 3 is equal to negative 3 now on this side because these two cancel. And now we can add 3 to both sides. And so now we see the 2x, because those will cancel, 2x is equal to 0. Negative 3 and positive 3 will make 0. If I divide by 2, 0 divided by 2 is going to be 0. So this one, x, is equal to 0. So you can see if I plug x into here, 2 times 0 would give me 0. All right, so our answer for that one was just 0. But once you go ahead and pause the video at this point and try 1 through 3, same thing as you're just going to, they all have the same base. So it should be very simple. You're going to cross out the bases. Your exponents now will equal each other, and they become the equation. And then you just solve for x from those. So pause the video, do 1 through 3, and then play it to check your answers. All right, so you should have an answer for now 1 through 3. Let's go ahead and see if you did these correctly. So for number 1, first thing you would do is to cross out the bases of 3, and that would then just now give you 4x is equal to 12. And then we would just divide by 4 to solve for x. When you divide by 4, 12 divided by 4, you would get x equals 3. So 3 is number 1. Number 2, they both have a base of 8, so the first thing to do is cross out that base. And then the exponents are the equation. So x plus 5 is going to equal 20. And then we just got to subtract 5 from both sides. 20 minus 5 would give us 15. So 15 is our answer for number 2. And then for number 3, they both have a base of 6. So we're going to cross out the 6's there. And so that's going to then give me exponents of 4x minus 5 is going to equal the 2x. So we write that down like that. 4x minus 5 equals 2x. Now we could either subtract 4x or we could subtract 2x. I decided to subtract 2x. Now you could have done it with the other way, and that you can still get the right answer. There's more than one way to go about solving some of these. So if I subtract 2x, that would now give me 2x minus 5 on the left side and 0 on the right side of the equation. Then I would add the 5 to move the 5 over to the right side. So add 5 to both sides. So now it give me 2x on the left side and 5 on the right side. And then just divide by 2. When I divide by 2, the 2's will cancel out, so it'll be x is equal to just a 5 over 2. So the answer there was 5 over 2, or you could say 2.5. That would be also the same answer as well. All right, so let's move on. So these were the easier ones to do with the same base. We're going to see how we're going to go into unlike bases now. So if we take a look at the next several, so 5 through 9 here is on this next screen. And what you notice now is that the bases are not the same. So you see you got 4 is our base here, and this one just says 1024. So what we can do is we need to change them to the same base. So, we could try to get this, we could actually simplify 4 to a smaller base of 2, because 2 squared is still a 4. But let's just see if we can change this one first into a base of 4. So we're going to use our calculator to help us on this now. So let me pull my calculator up and I'll put it over in this blank space. So I want to see, okay, 4 to what power might be this? So I'm going to raise my 4 up. I know 4 squared is 16. 4 to the third power, I know that one is 64. So maybe we want to go even higher than 3. So 4, I'm going to raise it up to, let's just say the fourth power. That's going to be 256. I need to go even higher than that. So let's try to the fifth power. 4, raise it up to the fifth power, and that's going to give me 1024. It's exactly what that is. So I can change this 1024 right here into 4 to the fifth power. And now I have 4 to the x, this expression power here, this 2x plus 11. So now I have the same base, and now at this point I can cross out those bases, and that would now give me the 2x plus 11, just like we did earlier on the last few problems, is equal to the exponent of 5. And then we just solve this by subtracting 11. And so we get 2x is equal to, if I take 5 away from negative 11, it's negative 6. And then we divide by 2. And so that's going to give us x is equal to negative 3. So we get negative 3 on this one. Let's go ahead and take a look at number 8, and then I'll have you try these ones that I've blanked out, 6, 7, and 9 on your own. Take a look at number 8. Now, 343. This one's got 49 to this power here. 49 to even the second power would probably not be 343. So we can try to bring this down a little bit here and see if we can do, okay, if I did 49 is a 7 squared, I know that. 7 squared, would I be able to get this to a base of 7? So let's try 7 to the third power for this one. So if I do 7, raise it to the third power, I can just do the Q button there. That is 343. So there we go. So this side over here, it could say 7 to the third power, and now I have the same base of 7. So this one here still already had an exponent of x minus 2. So this exponent right here, we're going to need to put in a parenthesis next to 2, x minus 2, and now that's a distributive property up here. I'll put my equal sign. We'll now be able to cancel out the base of 7. So the 7's cancel out. And then our exponents, I'm going to do the distributive property now. 2 times x is a 2x, and 2 times negative 2 is 4. So that's just the distributive property there. And it equals the exponent of 3 here. So now I just solve this by first adding 4 to both sides. And so it gives me a 2x now on this side because those cancel. And it's equal to 7. Divide by 2. And so this is going to end up being a fraction, so x will equal 7 over 2, or it could be, this 2 goes in this 3 times, or it could be 3.5. That would be okay as well. But that's my answer on this one. Either one of those answers, 7 over 2, or the 3.5. All right, go ahead and pause the video now and try the ones I have blanked out here, 6, 7, and 9. See if you can do these on your own. Actually, just do 6 and 7. I'll do number 9 with you in a minute. So just try doing 6 and 7, and then we'll come back and do number 9. So pause the video and do 6 and 7. All right, so hopefully you have 6 and 7 completed. You hopefully have an answer for those, and let's check to see if you did this correctly. If you don't, that's no trouble. Just see where your mistake is, and you always want to just check your mistakes. That's why we try the problems first on your own, and then if you do make a mistake, you can kind of identify that mistake. That does help the learning process. So we want to try to change the 512 into an 8, base of 8. Well, we know 8 squared is 64. So we could try 8 to the third power. 8 to the third power is 512. If you did that on the calculator, 8 to the third power would equal 512. So we got now the same base of 8. We can cross out those bases, and that would leave us now with the 3x, or the 3 minus 2x is equal to 3. And so I would subtract 3 from both sides to bring this 3 over here. It cancels them here. Negative 2x is on the left, and 0 is now on the right because we have 3 minus 3. So the same thing is true here. If this equals 0, then x has to equal 0. If you plug in 0 here for x, negative 2 times 0 would still be 0. So x is definitely 0 on number 6. For number 7, we have a base of 4. We'd like to try to change this 256 into a base of 4. When we were doing this problem, we actually saw that one. It was actually 4 to the 4th power. So 4 to the 4th power is 256, so that changes them to the same base. So again, when you don't have the same base, you have to change them to the same base. And so now we can cross out the same base of 4, and then our exponents become our equation. 7 minus x is equal to 4. And we're going to subtract 7 to bring the 7 over to the side where 4 is. So subtract 7 from both sides. 4 minus 7, it's going to give me negative 3. So negative x is equal to negative 3. We have a negative x because there's a negative sign in front of x. But we need our answer to have positive x. So you could multiply both sides by a negative right now, negative 1. And that would just change the sign. So positive x is equal to positive 3. You just change the signs of both sides there. All right, let's go ahead and take a look at number 9. So number 9, this one here, we have 6 and a 36. So 36 is going to give us 6 to the 2nd power. So we would want to change this to 6 to the 2nd power. And we would still have this exponent of 6x minus 1 that's going to multiply the 2nd power. So you're putting that expression in parentheses, and now you have a distributive property just like we did here on 8. So now you have the same base of 6. You're going to cancel out those bases. We end up with now distributive property. 2 times 6x is 12x. 2 times -1 is -2. And it equals the exponent over here, 5x. I'm going to subtract 5x from both sides. So 12 minus 5 is going to give us 7x minus 2. And then we're going to add 2 to both sides. So we're going to add 2 there. So that's going to give us 7x is equal to 2. And then when we divide by 7, we're going to end up just with a fraction of 2/7. So x is equal to this fraction of 2/7. All right, let's move on to our next number, number 10. I'm going to have you do a few of these as well. And they're going to be similar to some of these also. So we take a look at now number 10. Let me do number 11, then I'll have you do 10 and 12. So let's do 11 together. So number 11, we have 64 is the smaller base. Then you have the bigger one is 512. So we already saw 512. That was 8 to the third power was 512. 64 we also know is 8 squared. So this time we're going to change actually both of these into a smaller base so we can get the same base. So we'll start with 8 squared. So 8 squared is 64, but we still have this x plus 1 here. That's going to go in the parenthesis next to the squared. That's a distributive property. (512) is our 8 to the third power, and this x is just going to go next to that third power. And so now we can cross out the bases of 8. So we're crossing out the 8s. I'm going to do the distributive property with 2x plus a 2. And it's equal to this 3x over here. And we could subtract the 2x this time. We can do this way. Subtract 2x from both sides. That cancels our 2x's here. Leaves me with 2 just on this side. And 3x minus 2x is going to give me just 1x. I can just say x here. So there is our answer. X is equal to a 2. 2 is the answer for x. Alright, go ahead and pause the video and now do the red ones on top, 10 and 12, and then play it to check your answers for those two. Just do 10 and 12 and then check your answers. Alright, so hopefully you now you're checking answers now for 10 and 12. So on 10, we have a 9 and an 81. Well, we should know that 81 is 9 squared. So we just need to change that one. So the first one stayed the same with x minus 4. But now this is a 9 squared, and then we have this 3x to put in a parenthesis. We're going to need to multiply the 2 times the 3x. And so when we do that, we'll cancel out our 9s, our bases. The common base cancels out. So we have x minus 4 is equal to 6x now when I multiply there. So x minus 4 is equal to 6x. We could subtract x now from both sides. And that would now give me a -4 on the left side. -4 on the left side and a 5x on the right side. And so you can see here, I'll just move this all the way off over here. So we can see now we're going to be dividing by the 5 because we got to get x by itself. Divide by 5, -4 over 5 is our answer. So x is equal to a -4/5. On number 12, we have the same kind of situation we had back, I think it was on number 9, 6 and 36. We know 36 is 6 squared. So with this one, we start with the 6 to the 2x, and then 6 squared is going to multiply. The squared part will multiply the existing exponent here. Put that in parentheses. You have to do a distributive property. And so we cancel out our like bases now with the 6's. 2x is now equal to 4x plus 2. That's after you multiply them by the 2. 2 times 2x is 4x. 2 times 1 is 2. And we could subtract 4x from both sides. So that would give me now a -2x on the left side and a +2 on the right. And then divide by -2. And so that gives me -1. Move this off here. just -1 for my answer for x. So you should have got -4/5 for number 10, and number 12 should be -1. All right, let's take a look at number 15, and then I'll have you try 13 and 14. These ones now have some fractions in here, so let's take a look at how we would do fractions. Again, we're trying to bring this back to the same base. That's our goal here first, is to get the bases the same so we can cross out the bases. We have a base of 25 here on 15. So I need to make this into a 25, and actually I know that 25 squared is 625. So if I did that on the calculator, I brought that up here. If I do 25 and I just hit squared, that is 625, as you can see. So what we can do now for this one, this could be changing into the base of 25, but instead of putting 25 squared, that's just 625, to change it into a fraction like this with 1 over this, we got to put a negative exponent, -2. So 25 to a -2 power will be the same thing as 1 over 625. So as you can see on these ones here, to change this you'd want to make into a negative exponent. This one you'd want to make into a negative exponent with these fractions. So now we have an existing exponent right here of x plus 1. That's going to need to multiply the -2 here with a distributive property. And then we just need to rewrite this one over here. 25 is already the base. 2 minus 2x. So now we can cross out the bases here. So the 25s can cross out. 2 minus 2x is equal to, I'm going to distribute this, -2x here, and then -2. And so now when I add the 2x, I can add 2x to both sides. I can do that. And it will cross out my 2x's, my -2x, 2x here. But it also is going to do the same thing. It's crossing these out also. And so what I end up with is 2 now on the left side equal to -2 on the right side. So this equation, since this is not true, okay, since this is false, we could say, or not true, that means our answer is no solution. If that was true, if it said 2 equaled 2, then it would be infinitely many solutions. So this is something we should have remembered way back when we were just doing equations themselves. If you cancel out your variables, then you just got to look at what's left. If what's left is a true statement, then it's infinitely many. But if it's false, then it's no solution. This is not true. This does not equal 2 does not equal, we can put slash to that, a -2. So no solution. All right, go ahead and pause the video now and try 13 and 14 and see if you can get an answer for these. Remember, these fractions need to turn into a negative exponent. All right, so you should have paused the video. Now you're checking your answers for 13 and 14. So like I said, for this one, this could become 7 to a -1 power. And we would want to then see, okay, can this become 7 to some exponent? Can we change this into a base of 7? And you can use your calculator for that. What you probably should have done. Just, we know 7 to the squared is 49. 7 to the third power, we already saw that one was 343. So maybe like 7, if I raise it to the fourth power, what does that give me? There it is. So that's 7 to the fourth power right here. So I'm going to change this to 7 to a -1 power, but then we got to put the x next to that -1, and this becomes 7 to the fourth. And we can cross out the bases of 7, and now we have a -1x, or just -x, is equal to 4. So it just means we change the sign of both sides. So positive x equals -4. So there's our answer for 13. On 14, this is going to be 512. We need to change this to a base of 2. So we need to figure out how many 2's we need to multiply together to get a 512. So we can just try something pretty big here. We can go 2, raise it up to, let's say, the 8th power. If I do that one, that's 256. I'm not quite there yet, so let's try the 9th power next. So 2, raise it up to the 9th power, and there it is, 512. So 2 to the 9th power is 512, but it's going to have to be a negative exponent. So 2 to a negative 9 power would be the fraction of 1 over 512. And so now we already have a base of 2, and so we can cancel out the common bases there now, and the negative 9 is equal to the 3x minus 1. And I'll just show you the rest of this one here. Let's move this all the way off. So I'm going to add 1 to both sides. That gives me negative 8. Divide by 3, so my answer is a negative 8 over 3, negative 8/3 would be the best answer to say for that one. Alright, so let's move on to our next part here. We're going to actually take a pause here for a second with a joke of the day. So our joke of the day today is, how many tentacles does it take to make an octopus laugh? How many tickles does it take to make an octopus laugh? And I always say this one wrong, didn't I? Every time I do this joke, I always say it wrong. I always say how many tentacles, because that is the answer. Tentacles. 10 tickles. Oh, maybe one day I'll get that correct, but I'll say it the right way. How many tickles? I just can't help say tentacles, I guess. All right. Well, you guys get that. Okay, heading on to our next section. They're now going to be looking at using a graphing calculator to do these ones. So these problems here, it's still an exponential equation. The only difference is it's going to be a little bit harder, perhaps, to get this to be the same base. As you can see on this one, we have, we do have a 9 here, but we have a negative 9. So that might be a little more challenging when this is a 3, and this is going to be, I can make this negative, 3 squared. But that's going to be a little bit hard there. So the way we'd want to do these, like changing a 1/4, changing 18 into something where we can make that the same base, you really can't. You can't make a 3 and a negative 2 into the same base. There's just no way possible to do that. So in order to solve ones where there is no way to put the bases the same, to be able to solve it the way we've been solving them, we have to use a graphing calculator. So here's how we need to do this. We need to first see this as each side is a function of its own. So we're going to say y is equal to this, 3 to the x plus 3 power, and y is equal to negative 9. That's the first thing we need to do on this one, is just see that. And so now on a graphing calculator, we can now see that this is a system of equations, and we've already done systems of equations back in chapter 5. And a system of equations is where you have two functions, two equations graphed on the same coordinate plane. The answer for x is where those two intersect. So they intersect in an ordered pair. We're looking for the answer for x though. So we're just looking for the x coordinate of the intersecting point. So if I try this problem right here, and I do this one, actually, is this the one I wanted to do? I did want to do 3 of these and have you try 3 on your own. Yeah, so I'm going to do actually number 18 first. So I'll leave that there. You'll do this one. You'll plug those in. Let's actually start with number 18. Now the graphing calculator on a computer, the best graphing calculator is Desmos.com. So if you go to, come over here to like Google Chrome, and I need to do that. And let's try to bring this up. I have mine already here, but you can just type in up here Desmos, DESMOS.com, and enter. It takes you here, it says graphing calculator. So that's where you'd want to go for these. And it gives you this graphing calculator here. We're going to type our functions in here. There's 2 we're going to type in. So let's try number 18 first. I'm going to simplify this down a little bit so we can see this. So number 18 starts with, right here, y equals 3 to the x. So that's our first one to type in here. So when you type that in, you can click on this little keypad, and you could show keypad. And we could say 3 is the base, and now you have a squared. I don't want to put a square up there. That's 3 squared. I don't want to do that. What I want to do is I want to put a different base up there. I want to put just an x up there. So we could do it this way. I could hit this a to the b power, and now it puts an exponent up there. I'm going to put x, or you could type x on your computer. There's that function, 3 to the x, and it shows you that function right there. in red. Click on the next function to type in, which is this one here, -2, and then the exponent's going to be -x plus 1. So we're going to put a negative or a minus sign and then 2. And then I got to also do this a to the b power. And for this one I need to put a parenthesis in order to keep everything up here in the exponent. Otherwise it'll want to put it back down there. So I need to put a minus x and then a plus 1. So that's all up there in the exponent. I can then click here and get rid of that parenthesis, and now there it is. Okay, so what you see here, here's the blue one that we just put in, and the red one, our first one. Where is the intersecting point? Where are they connecting? And you can see they're not. They're never going to touch. So there's this kind of gap in between them here where they're never going to touch. So if they're never going to touch, then the answer is a no solution. So if your graphs do not touch, then you'll have a no solution answer. In order for you to have an answer for x, they have to connect, they have to intersect and touch. All right, let's try number 19. So 19, let's do this one here. So each of these is going to be its own function. Y is going to equal the left side, there's going to be a y equal to the right side, and we're going to put that into our Desmos just like that, and then see if we can find an answer. So I'll move this over to this side now. So I'm going to hit X out of these two, and now I can start over again. Now I don't need to put the y equals, but you can. Especially you do want to do that if you're going to put in just a number like this one, y equals -9, because if you just put in -9, that doesn't really do anything for you. So you would need to, on this one, put y equals -9, and now it shows up. So if it's just going to be just a number, you do need to put the y equals. But if you have a variable already over here with like x plus 2, you don't need the y equals, even though you can put it. All right, let's try this one. So I'm going to put 2. I'm going to hit my a to the b power to get an exponent. I'm actually going to hit the parentheses since my exponent is x plus 2. Now I'll show you why I need to put that parenthesis there, because if I put x and then I put plus, see the plus goes down there, and that's not where I want my plus. So I need to put it back up here, parenthesis x plus 2, and I can now click there and just get rid of that parenthesis if I want to, or you can keep it all in parentheses, it doesn't matter. So here's this graph right here. Our other graph is 5, a to the b power, my parenthesis, and it's x minus 3 this time, so x minus 3. And I can click, I'll get rid of that parenthesis there. So we could see these two now. Where is the x going to be where they're going to connect? So this one kind of comes up, this one comes up. So it looks like they're getting closer together. They're further apart, but they're getting closer together. The higher they go, the closer they get together. So I need to make my window. I'm going to keep pushing the minus sign to zoom out to see where are these going to connect. So it actually shows me that the connecting point is right there. It shows me that point when I click on the graph. It gives me like an the intercept's down here, but it gives me my intersection of these two up here. The x it shows me right here is 6.782. So that is my answer for number 19. It's the x coordinate of the intersection. 6.78 is approximately that. So that one you had to follow it up there on the Desmos calculator. As you can see, we had to zoom out and find it way up here. But if you click the graph, it will show you that intersection point, wherever it's going to intersect. You just got to find where they're going to connect. All right, let's do one more. I'll do 21. Let's come on over on this side now. Look at 21. So again, each side here is going to be its own equation, its own function. So y equals 1/4 x plus 1. That's a linear function, so it's just going to be a diagonal line. And here's another exponential. 2/3 is the base. 2x minus 1 is your exponent. So when I get the graphing calculator up here, let's start over and start new. And I'll put a 1/4. So we could do this. 1 divided by 4. So 1, actually I need to raise this up a little bit. There we go. 1 divided by 4. So it gives me the fraction. I need to click next to the fraction now to be able to put the x. So there's 1/4 x. It already starts with a line there. Then I got to put plus 1. So plus 1. So there's our equation, our line for the linear one, and that's going to 2/3. I need to put that in parentheses though, so 2 divided by 3 will give me the fraction, and then click next to it, and then we have an exponent button. I need to put parentheses as well because it's a expression, so parenthesis up there, 2x, and then minus a 1. And I can get rid of this parenthesis, or I could just, not. It doesn't make any difference. I could see there it is. I can even click it. Whoops, no, I won't do that. Get rid of that there. So it doesn't matter whether I keep this in parentheses or not. So now where is the intersecting point here for this one? And this one I'm way up. I'm going to zoom down into it. Zoom more into it, down in here. Okay, so there I can see there's the intersecting point. If I click on it, it'll show it to me. And there it is. It's there it is, 0.386. I'm going to round it up to just 0.39. So that's what this will say. So x is equal to the x-coordinate 0.39. So x is equal to 0.39. That's approximately what it is. Okay, so now what you're going to do is get to that Desmos.com on your own and do 16, 17, and 20. So do these three. See if you can find the intersecting point, unless there is no intersecting point and it has no solution like number 18 did. So go ahead and pause the video and then play the video once you've done that and just check to see if you are correct in what you're doing. Okay, so number 16, what you should have got on this one is that this one is no solution. These did not intersect. So you have the y equals -9, but then this is going to be above it. It's not going to touch that y equals -9 line at all. So you should have no solution for 16. On this one here, you have a y equals 18. You got to put it in with y equals 18. Now in this one you could put 1 divided by 4, just like within parentheses, or if you prefer, you could make it a 0.25. That's why it's showing here as well. You could have put 0.25 as your base. Now this one's going to connect right at 1.085. So right there, or you could have put 1.09. If you rounded it up, that's fine. But you should have got an answer of 1.085 if I show you that one. Let's take a look at that one real quick. And I'll put it in here. Let's start over with these as a fraction, just like I did before. So parenthesis 1 divided by 4. And then next to it, we're going to say negative. So I'm going to put exponent button, parenthesis, negative x, and then minus 1. I'll even get rid of that parenthesis there. And then y equals, you got to push the y on this one, y does equal 18. So that's there. So we can't see it right now. We have to zoom out so we can see it. So there it is right there. 1.085 is what we put. Or you could have rounded it up a little bit. And for number 20, on this one, again, each one of these is going to be put in on the calculator. And for this one, again, there's no solution on this one. They do not touch. So these two graphs did not touch each other, so there's a no solution for number 20. All right, we have just one more problem to look at. That's 22. Let's take a look at number 22. Number 22 puts it in kind of a real-life situation where we have a compound interest problem. He says you deposit $1,000 in a savings account that earns 5% annual interest compounded yearly. Write an exponential equation to determine when the balance of the account will be $1,500. Okay, so our exponential, or our compound interest is an exponential equation or a function. And so what we would see here, there's our formula. A would be the balance. Then you have your principal. Principal is the starting amount. 1 plus the rate over the number of compoundings. And then the exponent is the number of compoundings times the time. And so we can see that right there's the information of the A. This is our final balance here is 1,500. Our principal, our starting amount is 1,000. The rate 5% needs to be put into it as a 0.05. And the N, which is the number of compounding, says yearly, compounded yearly, which is just once a year. And so as we plug that in, we're now going to see 1500 is equal to 1000. And then in the parentheses, 1 plus the rate, 0.05 over 1. And then it's 1 times t up above. And so we simplify that then to just be 1.05 inside there to the t power. So this is the first part. This is A. So the answer for A is right there. That's our answer for A. B says solve the equation. Solve the equation for t. So basically we're trying to figure out, okay, what's the time? How long would it take for this balance to get to be $1,500? So to do this one, we're going to use the graphing calculator again. So we have to make each side into its own function. So we can say y is equal to this side with the 1000, 1.05t. I'm going to put x instead of t though. And then y is equal to 1500. And so we can bring back our graphing calculator. And let me make this a little bit bigger here. Yeah, let's start over. And we'll do the first one of 1000. And I'm going to put a parenthesis, 1.05 in the parenthesis. And I'm going to go past the parenthesis now to put the exponent of x. So raise it up to the x power. Okay, now we notice I don't see that on the graph because I'm going to have to zoom out here. Zoom way out. So there I start to see it there. Y is equal to 1500. I got to put the y in this one. Y equals 1500. Again, I got to zoom way out to see where do these two intersect. The intersecting point will be my answer for x or the answer for t. So there it is. Right here is the intersecting point. 8.31 is my answer for x. So my answer is just going to be 8.31 years. So it's about 8.31 years in order for it to, that's how long it will take for the balance to become 1500. If you start at 1000 to become 1500, it's going to take about 8.31 years according to this information. All right, so that concludes our lesson on 6.5. And so I will see you again on 6.6, our last lesson in chapter 6. Have a great rest of your day.